Ah, kids, hi, I'm back. Okay, now we're ready to go on to our next slide right here. But again, also you're definitely going to want your notebooks out because a lot of this is not going to be in that PowerPoint. So what I want to talk about and start talking about is how electricity and magnetism are related. There's a guy in 1830. Guy's name is not important. The time was not that important. There was a guy in 1832 named Hans Christian Ørsted, and Hans Ørsted, he was playing with Alessandro Volta's battery and a compass, and he realized that if you have that a compass needle lines up like it does with the magnetic field. I can, pretty easily show you. Take a compass. Let me do this. Sorry if you get a little seasick. You can see I have a compass right here and a magnet, and you can see that the compass will follow the magnet around. So the compass needle normally lines itself up with the Earth field, but it will line up with, if there's another field, it will line up with that other field. Well, if you take a look, I have a setup here. Okay, you can see the wire. Everybody see the wire right here? There's a big, nice, thick wire. I got my compass here, and then I got a bunch of little compasses there. See how the wire's coming straight up? And I have my lovely battery. Now, Alessandro Volta didn't have an energizer, but you get the idea. And if I hook my wire up, so I'm going to attach some leads to it. Now, I'm not going to leave it attached very long because I'm essentially shorting out the battery. But if you watch, just let me do something here. Okay. Okay, if you watch, I got to block the glare. If you watch just that compass, watch when I connect my battery. I connect my battery, my compass needle moves. So therefore, Hans Christian Ørsted determined, well, wait a second. That means there must be a magnetic field around a current-carrying wire. So that's really, really important. Number one is that there is a magnetic field around a current-carrying wire. So let's write that down. There is a magnetic field around a current carrying wire. Okay, very, very, very important. That's going to be really crucial, guys, when we talk about things like motors, electromagnets, all that stuff. That's really, really important. Okay. Second thing that I want to show to you is I want to see if we can figure out the direction of the magnetic field. So what does the magnetic field actually look like? So here's our handy dandy setup again. Okay, do you guys see the compasses are all lined up right now with the Earth's magnetic field? If I connect this, if you look how the magnets are actually going around in a circle, and you notice how all the red sides, which are the north poles, are kind of going around that way. Well, the magnetic field around a carrying wire is in the shape of a circle. So write that next. All right. So next thing we're going to do is we are going to figure out how to find the actual direction. Okay, bye kids.